rectangles, rhombuses, and squares. But prior to that, we had to say that those guys were all parallelograms. And what I want to do here real quick is kind of review our family tree. So if I want to talk about parallelograms, oh my. What are some properties of a parallelogram? Opposite what? What about them? Opposite sides are congruent. What else? Parallel, because the word parallelogram is in there. Opposite sides are parallel. What else you got? Go for it. We're just kind of reviewing all together. Today's just kind of a get our brains back. It depends if you know everything or not. It might not be a bad idea to rewrite it to get your brain back down. Hey guys, enough, please. There's a lot to go through. All right, consecutive angles. I had someone talk about this. Instead of the word consecutive, they used a different term second hour. They said angles on the same line. It makes total sense. I never thought of it that way. If you think about it, angles that are on the same line, here's the line here. These two angles are on that same line. So angles that are on the same line are supplementary. I like that definition. I thought it was a little bit cleaner than saying consecutive angles. So if angles share the same line, they're supplementary. They're supplementary. And there's, what else is there? Yep, diagonals bisect. And with those properties, we went through a bunch of algebra. We did some solve for x. We did some find the missing side length and things like that. It wasn't really anything all that crazy. After we went through the parallelograms, then we branched off into the family tree. What I'm saying by this whole family tree is that everything else that we talked about was in fact a parallelogram, but then it had more stuff to it. We talked about rectangles and rhombuses first. Well, what made a rectangle a rectangle? More specifically, there's only two parts to it that makes it a rectangle. Correct. They have 4 right angles. Can I slide this up? Are we okay? So there's 4 right angles. Can you remember diagonals are what the other important part was? Remember, Joe, everything that's already listed here, they're going to have. What makes it more specific is the right angles and congruent diagonals. The other one that was the quick branch off of the parallelogram is the rhombus. What made a rhombus then was the fact that it had 4 congruent sides. Yep. And there were 2 parts to it about their diagonals.
The diagonal bisecting.
Yeah, and they're perpendicular. When we talk about bisecting the angles, that means it's we're going to call them base angles. Is that all right? It's the angles on the exterior, the 4 sides, the 4 angles. The diagonals bisect those 4 larger angles, and the diagonals are perpendicular. The square then had all the parts. It had all the parts of the rectangle. It had all the parts of the rhombus. It was the most specific of all the parts of all. 4 right angles. Congruent sides. congruent diagonals. And diagonals. Bisect and diagonals are perpendicular. That's what made squares squares. Because it shared everything. And after you guys did that, you kind of just went through a whole bunch of little algebra problems. Again, solving for accidents. Nothing that wasn't too crazy out of the ordinary as far as complexity goes. One of the things that I have noticed. One of the things that I have noticed throughout the day today is that people are having just a really awful time recognizing what's what when you're just looking at a diagram. Why that happens is beyond me, but it seems kind of odd that you guys tend to make that mistake when you're looking at a diagram. For example, if I'm looking at it's easier to do. I'm just looking at this one. What does that have to be? What's the most specific name for that? Wrong.
No, it's a rectangle.
Wrong.
What?
Rhombus.
It's not a rhombus.
It's a rhombus. The arrows show that the opposite sides are parallel. The tick marks show that all four sides are congruent. But do you see anywhere in there right angles?
No.
Can you assume that they're there? No. You cannot angle side anything when you're working with these diagrams. You cannot do that. Okay? So the most specific name here is the fact that it has to be a rhombus. Now, what if you had just one? Is that enough information to make the square? Yes. It is.
Wait, because
It's
one is.
yeah, and that's the idea. And the idea here is, guys, that if you have just one of them being a right angle, since you know that you have your opposite sides parallel, as you go through that, you know that these guys are same side, same angles share the same line. The next one has to be a right angle, which means that shares it, that has to be, and so on and so on. So as you get into these things, you can't just automatically assume that it's a square because it looks like a square. I mean, this angle could be at 90 point. It's not a right angle. Get that? It's a smidge,
Yeah.
but it's not a right angle. Correct. So it's the idea that you can't just automatically assume something is by the picture. You have to go back and actually go through the process of figuring it out. Same thing here. What does this one have to be? Have we even talked about a trapezoid?
No, it's not.
You're right, it's not a rhombus. Good job, because 4 and 5 are not the same number.
It's a parallelogram, right?
It is a quadrilateral, but more specifically, it's a what? It's got to be a parallelogram. Very good. The only reason why it's a parallelogram is because all it has is the opposite sides parallel and opposite sides congruent. We don't know anything else about it. There's nothing else we can do. It's not a rhombus because the last I checked, 5 does not equal 4. And you know what? Every class period today, someone said, it's a rhombus. No, we gotta go. We're still on vacation mode. I get it. So, true. If you do that tomorrow, then we're just gonna shame you. What does that one have to be?
That's a rhombus. That's a rhombus.
The rhombus. Why is it not a square?
Because it don't have no.
It doesn't have no. It ain't got no English skills either.
Right angle.
Yeah, exactly. There's no right angles. You can't see it's a square. I'm not gonna lie. It's been the person that sat in the same seat all freaking day.
Yes. Not the first thing.
What's that one? Are you sure?
Looks like a rectangle.
It looks like a duck. Quacks like a duck.
It's probably the.
Probably a duck. It's a rectangle. Again, it's the same idea that so many people just tend to overlook these things and they make a dumb mistake. Now, when you look at the diagrams, it's for some reason more difficult for you guys to do it via diagram, but yet if you look at it in terms of a list, you'll get these right all day long. For example, what shape or shapes have all sides congruent?
No, square.
Square and a rhombus. Okay. What shape has opposite sides that are parallel? A rhombus, a square, rectangle, parallel, all of them.
Yeah.
Yeah. All angles are right angles.
Square.
Squares.
Rectangle.
And rectangles. Okay. See how much it's so much easier to you guys if you read it in words instead of trying to work off a diagram. But yet it should be the other way around. I don't know. Diagonals bisect each other. Everything, all of them, all the parallelograms, diagonals bisect. What about which ones have diagonals that are perpendicular? Squares and rhombus. Very good. Squares and rhombus. Okay. Diagonals congruent are squares and rectangles. Perpendicular are squares and rhombus. All right. Which ones are opposite sides congruent?
Oh, that's parallel.
Yeah.
Right. All of them. All four of the shapes we've looked at. Opposite angles are congruent.
Parallel.
All four of them again. Consecutive angles are supplementary.
All of them.
All of them again. Congruent diagonals. All of them. Rectangle and
Square.
square. Again, as you go through the terms in lists, you usually pick up on it easier. Okay? The lists of them are easier to go through. Diagonals bisect opposite angles.
I just have diagonal bisect.
All right, diagonals bisect. What this means is, if you're looking at a shape, diagonals go from opposite angle to opposite angle, so they bisect the opposite angles. So that means it's a
And
no
oh, it's a square.
or a. Very good. It's either a square or a rhombus.
It's uniform.
Which then means you can do algebra. So, one of the things you guys have done in the past, you've been given specific information. For example, you might say that you have a rectangle, what is it, L, M, N, P. You have that rectangle, and it gives you specific segment lengths. You need to figure out what segment lengths they are. So what should you do to figure out what those are representing? Exactly. Now, when you draw out a rectangle, does it have to be absolutely perfect? No, it doesn't. As long as you know that it's rectangular-ish in shape. Now, when you go to label it, does it matter where you put L to begin? No. What matters is that you go in order as you work your way around. So if I start there and I go clockwise, what's the next one have to be? Yeah. It's been the same rule for that throughout the entire semester when we did triangles and such and whatever. Just the labeling is how it cleans itself out. Which then means that you have LN, which is a diagonal, and P is another. You've got to draw a diagonal, but you get the idea. I haven't drawn in a while. Which means what has to happen for the diagonals to work? If it's a rectangle, diagonals are what of a rectangle? They're equal.
Yeah, they can
So you have to do a two-step algebra problem. So when you have to go through and do a two-step algebra problem, you have to remember how to math. According to my observationalness today, mathing skills have kind of they've been frozen out, shall we say, a little bit. Smidge. Okay? So if I have variables on both sides of an equation, what do? What do you do? Yeah, think on the little guy. Okay? Remember, as you're doing the algebra of this stuff, subtract the small guy and move the other stuff at the same time. What's the value of x? 9. Now, just a quick reminder, it's not always just solve for x. It's yeah, you have to take the value of x and go back and substitute it in. Now, when you get into your finals and stuff as they come up, one of the things that, I don't know if you've really read through this quite yet, one of the things that we highlighted on the very front page of this is that how the questions of the file itself are written. There's only 45 questions. Okay? Not a lot. You have vocab, multiple choice proof, which there's examples of what they look like on the back. And then you're going to have 15 free response questions. Now, the free response is kind of like a helper, shall we say. Because if you think about this, if it was a multiple choice question, and you had A, B, C, D, and one of them was 9, one of them was 67, this one is 63, and this one is 11. I don't know. And right off the bat, you just solved, you got 9, and you fill in your little dot of D. Are you going to be right or wrong? You're going to be wrong. Because what did the question say? Solve for x and... Okay. So you'd have to go back and substitute. The reason I wanted to point that out is because this is a very common thing that happens on finals because they're multiple choice. Multiple choice tests are not the nicest thing to math tests because it's so easy to work it out correctly, but then go to your list of stuff and not read the question carefully. So that's why what we've done this year with the rewriting of all the finals and stuff is that we added those 15 questions of the free response. Because let's say you wrote down your answer was 9, but yet it was asking you to solve for NP, where all you had to do, like you said, Joe, was take that 7 times 9 and add 4. So your true answer would have been 63. If you wrote down 9, you just miss a point. I think yes, I was checking to make sure you guys were paying attention. Good work. Thank you. Nicely done. So if you did that, then you'd get a point off, but yet you're still getting some point value to the question. Whereas in a multiple choice test, it's just wrong. Okay? There's no partial credit for doing the work. Even though you know how to math, you just didn't know how to read. So that's why this test can be a little bit different this year as far as how the finals are done. I don't remember if they did that last year with the Algebra 1 test again. I know for geometry and for my honors class, it's all different this year with the write-out ones. Okay? So you just have to read questions carefully. Same thing goes for solving out. If this is going to be a square, take a minute and solve for x and y. What are the values of x and y that makes that a square? Take a minute to do that. How about the side lengths? What do they all have to be? They all have to be equal. So I can't solve for x and y at the same time, though, can I? So I've got to solve for the y's. Now, there's 3 sides with y's in it. Does it matter which 2 I choose? No, makes no difference. You can pick any one of them, and it'll still work. So if I say that I have y minus 1 equals 3y minus 9, subtract the y, add the 9, so I get 8, and I get y is 4. If y is 4, what are my sides? 3's, good. All my sides become 3, which means that if I set this equal to 3, what does x have to be? Good. We okay with that? Again, it's the idea that you choose 2 of the 3 sides that give you the value of y, to go back and solve for it, to figure out what the side length is, to then therefore to solve for x. It's not a complicated thing, but you'll notice you have to do 1, 2, 3 different parts just to solve for x and y to make it work. 2x. Like this one. Now, if this is going to be a parallelogram, I want to solve for x, y, and z in that one, given that it's a parallelogram. Well, what we have to do then is figure out what kind of a parallelogram it is. Take a second and see if we can figure that out first. So what? Why? Because of the one right angle. Since it tells you that it's a parallelogram, when you have a parallelogram, that means you have opposite sides that have to be congruent. So if you look at it, this top portion here gives you basically an isosceles right triangle. You okay with that? So you've got your 2 sides that are congruent. Now, if that's going to be, these 2 sides are congruent and it's a parallelogram, that means that the opposite sides also have to have the same amount of tick marks. And just like we did a second ago, we mentioned that if it was a parallelogram, if you have one right angle, then therefore you're going to have all right angles. Okay? Now, with this then becoming a square, these diagonals do what to these angles here and here? Bisects them. It dissects it and bisects it. Julienne's fries does all that. If you bisect the 90, what are you left with? Good. So you have your 9x has to equal 45. The 6z has to equal 45. And then what does angle 1 have to equal? Good, but what does 3y minus 6 have to equal? 90. Why? Because what? No.
No, yeah. Oh, yeah, it's in the middle.
Because the diagonals are perpendicular. So lines up once you use your properties real fast. You get that 15 over 2, press a button on the calculator, it gives you 7.5. Is it okay to get a decimal? Yeah. Now, I will say one thing. With multiple choice questions, it could either be given you as your selections could be simplified fractions, or they could be simplified decimals. So you have to know how to use your calculator to work between the two. Whether you hit the double arrow button, or if you've got a calculator that just automatically does decimals, how do you go back to check the other ones? You know, is 5/6 going to be equal to whatever decimal that you have written down? That kind of stuff. So you have to be able to know how to use your calculators. Remember, I won't have calculators for you, nor will I have pencils, because you have to have a pencil. Right? You know what? They say you're not supposed to, but I've never seen a mechanical pencil that didn't work. Or find me a number 2 pencil that's not a number 2 pencil. Or find me a pencil that's not a number 2 pencil. I know that, all right, some of you guys say, in my drafting class, or art class. And I know there are pencils that aren't that, but I mean, you're artsy. You draw really well. Do you have pencils that are number 2? What are graphite pencils not number 2? Oh, all pencils are graphite. Is it a number 2?
Yes.
What is it?
The number it's a specific size, not size, it's the density. It's the specific density of the lead. Not too big? Is that the question?
There's 2Bs, there's H, there's like an HB.
Thank you.
I get what you're saying.
Yeah, all right, so there are, I know there are, but for, okay. Yeah, so it gets right for different shades, because different hardness levels maybe?
Yeah.
Okay, makes sense. What I have posted for you guys is some review junk on 9th, or not 9th, it's the 6th form. Now, what I did was I'm using the old worksheet again from the old textbook because they've got some really great algebra problems and whatnot. I already posted it on the calendar, so there's a PDF file for you. I'd like you to do numbers 1 through 26. This will at least get you started on the first portion of it if you want to start on that now. That's really what I had to go through today. Tomorrow, like I said, we'll get into 6-5, 6-6 Friday, the coordinate stuff on Monday, review it, and test it a week from today. Okay? There you go.
The right side.